All right, we're in topic 4-5 looking at example 2. In example 1, they walked you through the process of factoring expressions. And so looking for common factors within the different terms, and then of course factoring them out to get an expression that looks like a, well, there's a multiplication problem and then an equation inside parentheses. Example 2 continues to look at this concept and kind of wants you thinking about this idea in a way that a math student at your level can and needs to be thinking about it. All right, so we look at this idea. It says Rodrigo and Jordan each factored the expression negative 2x minus 6. Who factored the expression correctly? So if you look down at the problem, you see that they both came up with a solution, right? On the left side, Rodrigo came up with a final answer of 2 times the quantity negative x minus 3 is equal to negative 2x minus 6, where Jordan came up with the expression negative 2 times the quantity x plus 3 is equal to negative 2x minus 6. So at this point, we want to kind of check their work, looking at their picture to make sure they're doing their math correctly. That's going to let us know if they did it right or if they did it incorrect. So to distribute this, right, I would take this 2 and I'd multiply by this negative x. So 2 times negative x, that's what we're seeing right here also, 2 times negative x equals negative 2x. All right, so that part we would agree with. Second, of course, using distributive property, you would do 2 times the quantity negative 3, which is what we also see right here, right? Here's the 2, here's the 3, and the multiplying. So 2 times negative 3, of course, equals negative 6, so negative 2x minus 6. All right, so Rodrigo's work looks good. So now if we go over to Jordan's, we're going to look at his process. His process, right, he factored out a negative 2 on this side, and negative 2 times x, he's going to say, is 2x, which he is also correct. Okay, so here's the big thing. Did he do the next part correct or not? All right, so we're going to take this negative 2 again, and we're going to multiply by 3. Right, here's the positive 3 right there. So negative 2 times 3, we got to get an answer of negative 6, and it's right. So how is it that our two answers are different, right? Our answer here and here look different. They are different, right? So we have that idea. Here's what's going on. If we take a closer look at what these two gentlemen did, we see that they're both correct. How can they both be correct? They're both correct because they're using different kinds of factors. First of all, we see Rodrigo used a positive common factor, and in this case he used 2 as his positive common factor, which for this problem worked out really well for him, and it allowed him to come up with this expression and was correct. We just showed that on the previous slide. Jordan, on the other hand, decided to use the negative common factor. So this is kind of where we're stepping into more of a different realm of factoring, is we can factor positives and negatives. And so that's where we're expanding our thinking. Sometimes we got to take out the negatives as well, right? And sometimes the answer, there is no right or wrong explanation as long as it works, right? Sometimes you can just use the positive, sometimes you can just use the negative common factor, and both answers will be correct because you used the correct factoring sequences, the correct patterns to solve that problem, and you get an answer. And so what we're starting to see is that in math, especially when we don't have a final answer, right? We're just using an expression. Sometimes we can have a positive answer and have a negative answer, and both of them be correct. Right? And so that's what example 2 is showing you here. All right, then in the try it, it wants you to do just that. It wants you to take this expression and think about how could you factor it taking out a positive factor. How could you also factor this taking out a negative? Right? So that those two different ways. All right, go ahead and do the try it. Pause the video and then move on to example 3. All right, then as you move on to example 3, we're starting to see that while terms 6x, negative 18, negative 12y can't always be combined. That's what we looked at the first part of the chapter, is how can we combine like terms. Even though not all the terms are alike, we still can factor terms even when they're not alike because of the numerical references to it. So we can simplify our factoring by using the same techniques we've used in the past when it comes to factoring numbers, by using the GCF, also known as the greatest common factor. So in this example here, it says we have a 6x, an 18, and a negative 18, and a negative 12y. So as you look at that, we can take the numbers 6, 18, and 12, and we can start looking for the greatest common factor between them to help us understand what we're going to factor out of the entire expression. So I know that 6 is made up of 1, 2, 3, and 6, right? 1 times 6, 2 times 3. So if I go 18, I got 1 times 18, 2 times 9, 3 times 6, and then 12, of course, is 1 times 12, 2 times 6, and 3 times 4. And so now I start looking for things that match, and of course I'm looking for G, the greatest. And so as I look for the greatest, I come away with understanding that 6 is the greatest. Okay, now that I've found that greatest common factor, now I can factor it out of this expression. All right, so you see, if you don't like my messy handwriting, you can see they're neat expressions here. And looking at this idea, and now that we've found that the greatest common factor is 6, we're going to, I'm going to click next, and now we're going to use the greatest common factor and the distributive property to factor the expression. Right? So basically what we're seeing here is just this idea, is that we have, right, we see a 6 times x, we see a 6 times the 3 here, and we see a 6 times 2y here. That's how these expressions and terms fit together. So if I take that 6 out, what we should see is put the 6 on the outside and leave what's left over on the inside. So x minus 3 minus 2y. All right, so let's see if we did it. All right, my answer disappeared, but you can see that we did factor correctly. 6 times x minus 3 minus 2y. So we have that idea. All right, that is topic 4-5. All right, work through the lesson. Circle any questions you have. If you have additional questions based on what you're seeing right here, make sure that you write those questions down so that we can solidify your understanding. All right, until next time.